So hello everyone, welcome to the fifth webinar of the Preparing for the PAT course 2025. My name is Kat, my pronouns are she, her, and I'm the Access Officer for the Department of Physics. So I run most of our programmes for secondary school students, including all of the stuff to support students interested in applying to study physics here in Oxford. This session is being recorded, I'll make it available to you tomorrow. A quick reminder of the housekeeping rules for those of you joining us on Zoom. You will be able to use the Q&A for any questions that you would like to be addressed, and I'll let you know when this is switched on ready for you. You can also use the chat to share any of your thoughts, but keep it polite and kind. Don't share any personal details or information, and don't use it for questions that you want us to answer. So any questions in the chat are unlikely to get answered. Make sure you pop them over into the Q&A instead. If at any point you are feeling unsafe or concerned about anyone, you can contact our safeguarding lead on safeguarding@physics.ox.ac.uk. But with all of that done, let's get started. I'm not going to be taking questions during this section, but before we get stuck in with our tricky problem-solving webinar, I'm going to give you a very quick introduction to the course and to the PAT itself. Quick reminder as well that if we don't get to any of your questions, don't panic. We've got an extended webinar on our final webinar where we will also be joined by representatives from the Materials Science Department and the Engineering Department. But first things first, the PAT is the physics admissions test at Oxford University, and it must be sat by all candidates who are applying to study physics, physics and philosophy, engineering and materials science. The PAT forms part of the information which admissions tutors use to decide who to shortlist for interview. To sit the PAT, you must register yourself as a candidate. Your school will not do this for you. The PAT this year will be on screen and multiple choice at Pearson test centres. This is the same arrangement that we had in 2024 and very similar to the arrangement for the ESAT, the BMAT, the LNAT, lots of other admissions tests. It's also kind of similar to the driving theory test, I believe. The online test will include a built-in calculator, which looks just like a regular calculator and works in exactly the same way. There's a practice of this which I will share in just a minute and that I share in every email. This webinar is part of the PAT preparation course, which the physics department run on behalf of all of those subjects. It's a set of 8 webinars along with problem sets and summer assignments, and we hope that by the end you have all the information you need to take the PAT, to help you prepare for the PAT and to be confident going into interviews if you're shortlisted. The timetable on screen at the moment is a screenshot of part of the timetable, which is at the bottom of every PAT email. And I always highlight it in yellow so that you can follow our progress. And in each session, I'll always fill you in on any updates or news. Today, as you can see, is our third study focus session, and we are focusing on tricky problem solving. You can find all of this information, so you don't need to memorize it, about the course and all of the course materials on the course materials page. I linked to this in every email, but you can also search for it really easily. And at the moment, the bottom of that page looks like this. There's an introduction to physics problem solving at the top of this page. And that's got some general hints and tips, which our colleague Rachel developed in the first webinar. And on the rest of the screen, there are links which you might need. So for example, we are currently at webinar 5. The link to tonight's live stream and recording is already there. The problems that we're using are linked, and I'll also share them in the chat in just a second. Finally, just a quick reminder that all of the information about the PAT that both you and your school might need can be found on the page on screen at the moment. That link is in all of the Preparing for the PAT emails. It's the most up-to-date page and the one to check first for any information that you need. It also has a surprisingly comprehensive FAQ page. I think almost everything that I've been asked, I've been able to find. Not everything. Some people ask some more difficult questions, but almost everything. Some key facts to finish us up before we get stuck in. As I have already mentioned, all tests this year will be sat at Pearson test centres. To expand on that, these venues are in almost every country around the world, so it is the same process for everyone. And when you register, you're able to select a centre which is most convenient for you. For some of you, that might involve a little bit of travel, but hopefully not too much. And as I already said, it's the same setup for tests like the LNAT, the BMAT, and the ESAT Cambridge admissions tests. The PAT is completely free to register for and to sit. And if you're eligible for any access arrangements, such as extra time, you can apply for them when you register. Registration is already open and is open for another 9 days. So if you're not already registered, get yourself registered, and you can book your test slot from now until the 26th of September. So again, get yourself booked in. We're starting to hit the last couple of weeks where that is an option. The PAT itself is going to be on the 22nd and the 23rd of October, and there are no alternates to that. So if you think you're going to be away, you're going to need to find somewhere else to sit the PAT. So you may end up sitting it in a city that you happen to be travelling to at the time. As I also mentioned earlier, the test format was new last year, but the questions were, and will again be, really similar to those in our past papers, and the syllabus has been unchanged since 2018. There's a sample paper which you can access and you can have a go at using the calculator through it as well, is on the link on the page. Again, I will share that in just a second. And I'm also going to share a video of how to get the most out of that online test platform in the next few days. There's a video of what it's like as you go into the test centre and walk in and register. Again, I will share that tomorrow morning. You're probably getting this idea. But hopefully that gives us everything we need for now. That is my quick PAT introduction and update. Hope it was helpful. I will answer any questions that have come through, but for now I'm going to stop screen sharing and hand over to Justin for our problem solving.
Thank you very much, Catherine.
It's always a bit of a mouthful, that bit.
It was, but
I've got a lot to get through very quickly.
Very, very rehearsed. Let's see if I can be as rehearsed as that. So let's just pull up the slide for today. So there's, I think, 4 more sessions that you have. I'm going to be doing some live stuff at 2 of them. The other ones, you have some kind of like workshop questions, which I think I wrote. It was quite a long time ago that I was involved in setting up this course, but hopefully they're still the questions that I put together. So I am Dr. Justin Palfreyman. I spent about 9 years at Cambridge, but it turns out that physics and science supersedes any kind of like rivalry between Oxford and Cambridge. I never rode. I didn't do the varsity match and play rugby. So we actually quite like each other. And,
absolutely.
So you'll see here that I'm a teacher. I've been teaching A-level physics for 12, 13 years, something like that. For the same length of time, I've also been an examiner. I've held pretty much every role you can think of that an examiner might do, including principal examiner, writing exam papers, mark schemes, remarking things. I've just been finishing doing a bit of that. Isaac Physics started about the same time that I started teaching, so I've been involved with them from the start. I dabble with STEM learning, doing some kind of like CPDs and masterclasses, and if I can find any spare time, you might be able to ask me to do some online tuition. Let's have a look at some of the problems we're going to work at today. We've got 10 to get through, and these kind of problems, you might say, I'm not going to see a problem like this in the PAT. In the next session, you might see kind of like more traditional PAT questions, and I might actually try to teach you something. Here, I'm going to have a bit of fun with you, and some of you might find it a little bit torture, but that's fun for me anyway. The point of these problems is to make you a flexible problem solver. I've applied to go on the 1% Club. They didn't want me for season 4. Fingers crossed they'll phone me for season 5, because if they do, based on past performance, I've got a 50-50 chance of winning it. Why? Because it's all about lateral thinking. And that's what these problems are. And a great physicist should be able to break down problems and solve them when other people can't. So most of these problems that I'm going to give you, yes, I'm interested in you getting the right answer, but I'm also interested in how you got that answer because there'll be a hard way that you might see straight away. But if you take a step back to analyze the problem and think about, is there some symmetry here I can use? Maybe I can draw some extra lines and then everything will make, or, instead of asking this question, maybe I ask the opposite question. And how is that related? You'll see what we mean when we get to some of these particular examples. So it's about giving you a set of tools that you may have or may not have polished yet for how to approach these kind of problems. And yes, some of them are maths problems, some of them are logic problems, some of them, they are related to physics as well. But we'll see as we go along. So the idea is, please don't be on YouTube because I want you to type in your answers, not to everyone, but to the panelists, please. And if you get the answer right, I'll say move on. Hopefully, you've got a link to the workbook. You've downloaded that. You can get started on the next one.
I've
I'm going
just
to,
added that. I tell you what, Justin, shall I
yeah,
make it so they can't chat to each other?
yes, stop chatting to each other. Don't ruin it. Don't spoil it. Let me open the chat. At some point, this is going to go so fast that I'm not going to be able to keep up, but I'm going to try to give people a shout out um, if they've got it right. Do not forget units, please. Uh, Jeshurun, move on. Oh, hang on, loads coming in. Goal, no, too high. Rosa, move on. Tanishka, too low. Evie, too low. Colton, move on. Kelvin, I'm not answering until you give me units. Units are incredibly important in physics. Too low. Ellen, what did I just say about units? Fallet, too high. So we're going to have about 5 minutes roughly on each of these problems. After every couple of minutes, I might reveal some little hints and a bit of guidance. Kelvin, good. That's correct now. Was that the same, Kelvin? Yes. That's what I like to see. Resilience. Make a mistake, correct it. M, too high. Ria, correct. So about half of us are getting this one first try by the looks of it. And the torturous part is when I tell you that I stole this question from Singapore because it was given to primary school children. Said too low. So there's something going on in Singapore where they're teaching the children how to solve problems like this. Ihan too low. Tanishka too high. Evie, yes, we've got it. So here's the first hint. Draw some lines. Okay. Arpith too high. Ali too low. Mahika correct. Ryan correct. Leo too low. Freddie too high. Dan correct. Victoria too low. Tanishka, third time lucky. Yes. Well, not lucky, but it is going to be an integer. Yasmin, it's not going to be. You can do it without a calculator. Uh, Mishka, too low. Cedric, correct. No, sorry, not correct, Cedric. Too low, but not far off. Eric, too low. Ihan, correct. Lily, too high. Rodrigo, too low. Okay, Rosa's on to question two already. Yes, fine, move on. Tabitha, too low. Units, please. Demir, correct. Yes. Ishita, correct. Goal, yes, is now correct. Question 2, Ellen, is also correct. Okay, I think it's time to move on with this one. So the answer, well done, those who got it, 68 centimeters squared. So this central rectangle, when we draw these lines on, well, this is going to be a 2 by 8 rectangle. So that's the first thing to note here. Okay, so hopefully we can see that. This length is 4, this length is 2, so this is 2. And similarly, this is 12 and this is 4. So this is 2 by 8, so we can work out that area. Now, if we look at these 4 other sections, we should notice that half of the area of these sections is shaded. So if we take away that 16 from the total area, we're told the total area is 120. So these 4 sections make up 104, and half of that is shaded. So then we add back on that 16 at the end to give us the 68 there. Very good. So let's have a look at question 2. Colton, thank you for giving me the obvious wrong answer. Otherwise, the answers that I'm seeing, I think, are mostly correct. So the idea here is we have a little ball at the top of a hill. We don't know much about the hill except that it's smooth. And if we give it a tiny little nudge, it gains speed as it rolls down the hill, and it comes out at 4 meters per second. So what would happen if, instead of it starting from rest effectively, I gave it a push and it started at 3 meters per second? What would be its velocity at the bottom? It looks like a lot of you are finding this quite straightforward. So I'm not going to name drop except for ones that I think are wrong. Isabel is too low. Fabian is too high. But otherwise, if you put in an answer, I think you've got this one correct. So move on to question 3. Looking good so far. Okay, Ellen, if that's your answer to question 3, it is too low. Okay, Mal and Orion, you've both given the obvious incorrect answer. GKM, that is correct. But did you do it the clever way? Or did you make sure you weren't doing double and triple counting? Let me know if you think you did it the clever way. You'll know if you did it the clever way. How would I know? Okay. Albert, is 18 the answer to this? There's no units, so I'm not quite sure. So Jasmine was too high. Jemima has given the trick answer as well. Okay, Kelvin, too low if you're looking at question 3. Mahika's too high on this one. We don't need calculators. There's no square roots. Well, there is square roots, but I've chosen nice numbers for you. Too low, Sophia. Oh, trick answers. Gabriel, Iris, Zema, all going for just thinking that I can add 3 and 4. That's not how you work out kinetic energy. Ryan, correct for question 3. Do you know if you did it this clever way or not? Number 3, you've got correct. Did you do it the clever way? Rosa, too high for number 3. So let's have a look at this one. Most of you got this one pretty quickly. Jeshurun, that is the clever way to do question 3. So for this one, let's just do a quick little reveal. It's conservation of energy. We don't need to know the height because from this first scenario, mgh is just half mv squared. So we can substitute for mgh into here, And we don't need to know the mass because we never need to know the mass for these kind of things, really. So the mass is going to cancel out. So because I've given you very nice numbers, hopefully this pop-up bar isn't blocking this, but it's basically a Pythagorean triangle. 3 squared plus 4 squared is equal to 5 squared. Okay. My twos, why are you giving me something with no units? Interesting. So let's have a look at question 3. So here we are considering a megacube that is made out of 1,000 normal cubes. So a 10 by 10 by 10 megacube. And the question is, how many of those 1,000 cubes have a surface that is on the outside of the cube? Tabitha, too high. Matthew, too low. Ooh, Evie, you have it correct. Oh, it's going so fast. Okay. Oh, I'm not going to be able to keep up with this anymore. Um, so many answers. So Arpith is correct. Victoria is correct. Dan is correct. So let's just try and shout out some of the correct answers. Eric, correct. Billy is correct. I will tell you that it's somewhere between 450 and 500 because there's a lot of answers outside that range. Jemima is correct. Dinanda is correct. Johan is correct. Okay. Miko's correct. Robin's correct. William H is correct. And Said is correct. Okay, I've had one person tell me their method to tell me that they've done it the clever way. Does anyone else think that they've done it the clever way? Archer's correct. Julian's correct. Matuz is correct. We're getting the right answer now. Matthew's correct. Okay. So I've seen someone else tell me their method. The method is to ask here the opposite question. So it's very easy to ask the question, how many of these cubes are on the inside, i.e. not on the outside? So if you imagine on the inside of this, if you peel off that layer, you're going to be left with an 8 by 8 by 8 cube. And 8 cubed is 512. So what am I left with? I must be left with 488. So asking the opposite question. And quite often I find if you've got a probability question, then this is quite an easy way to work it out. What are the odds that this happens? Well, what are the odds that the other thing doesn't happen? And then do one, subtract that, because it's often a lot easier to work that one out. So 488 is what we're looking at here. So we can apply that technique in quite a lot of examples. Let's have a look at this bartender for question 4. So we pour 100 ml of tonic water into one glass and 100 ml of gin into another. We then take 30 ml in a shot glass, scoop out the gin and mix it into the tonic. We then take another 30 ml of that tonic and gin mix and put that back into the original glass. So is there more tonic in the gin or more gin in the tonic? I know some people answered this before, but that is way in the past now in the chat. So let's have a look. Okay, Rosa has the correct answer, as does Victoria. Ryan and Jeshurun. Elisa. I mean, in a sense, this is slightly a trick question. Evie's correct. Denaja is correct. Ericum is correct. And Colton, yes, the trick question is that it is neither, is the answer. So you could calculate it if you wanted to, and you can calculate it without a calculator. It's not too tricky working out those fractions, but we can think about this in a different way. So rather than thinking about it in terms of liquid, let's imagine that I've got 100 red balls and 100 blue balls in two buckets. And I take 30 of the red balls out and I put them into the bucket with the blue balls. So give them a good mix, and then I take 30 back in there. So I've now got both buckets have 100 balls in, and there's 100 red balls and 100 blue balls in total. So whatever number of red balls is missing from my red bucket must have gone into the blue bucket, but I've still got 100 balls in that bucket. So I must have replaced them with blue balls. So yeah, it's got to be the same. So that's the easy way to think about it. No need to do the complicated math, but you can do it the math way, just if you wanted to verify and actually work out what the concentration is at the end of it. So the glasses, they start and end with the same total volume of liquid. Let's see, can I move this out of the way? No, I can't. That's slightly annoying. So any gin that is missing from one and in the other must have been replaced by the same amount of tonic from the other glass and vice versa. So let's have a look at question 5. I can see some answers have already come in. Who's that? Ryan is correct. Dinanda is correct. So we've got 2025 people in a race, and they're all numbered randomly from 1 to 2025. So what is the probability that the first 3 runners to cross the finish line are numbered in ascending order? So it doesn't need to be numbers 1, 2, 3, or 5, 6, 7. It could be number 204, 511, 714. That would count. Billy is correct. Jeshram's correct. Taylor, I didn't see your answer to number 5, I don't think. Sophia is not correct. But for number 6, Jeshurun, that is not correct. Ryan, I think I said you were correct for this. For number 5, Taylor, thank you, that's correct. Rosa, not correct. No, Dan, just that's crazy. Question 6, Ehan's correct. Question 5, is correct. Ruben is not. William, no. Ooh, Mahika, very similar answer to Ruben, to Williams, actually. Some very big numbers coming in here. James, no. Thomas, very low, low number. Okay, I'm just going to focus on question 5 for now. Let's not get too far ahead, but if you're confident, feel free to move on. When we get to the cows, that's really going to slow you down. Johan is correct. Question 5, Evie is correct. Ria is correct. M is correct. Dave and Demir are correct. Alistair and Grace, sorry, Isabel, are incorrect. Zarin, I don't know what N is. Eric, no. Chinmay, no. So far, we've not needed a calculator. That is also true of this question. So, Sed is correct. Pallet's correct. Albert is correct. Seeing lots of things that would possibly involve calculators, so I'm going to dismiss those. Leo is incorrect. Where are we getting 1 over 2021 from? Gabriel's incorrect. Brian's incorrect. Sophia's incorrect. Okay, let's drop a hint. Let's imagine. Well, actually, I asked this question last year, and the answer was the same, but there was only 2024 runners. and the year before there was 2023. The answer's always the same. It doesn't really matter how many runners there are as long as there's more than two. Because we can just label them A, B, and C. Let's get rid of the numbers. Let's just label them A, B, C, the first three who crossed the line. So another correct answer. Gracie's correct. Someone else that I just missed. Can I get back up? So, sorry. Don't do that. Let's highlight the chats. Try and scroll. Victoria's correct now. Adam's correct. Matthew was correct. I think that was the person I missed. Ilania's correct. Fallet, are you giving me a calculation to do? You can do 3 factorial in your head, surely. Okay, now we're getting there. Loads of correct answers, except B. And then some incorrect. No, these are correct. Or Miko, not so much. So there are only 6 possible ways that these could be ordered. These ABCs, ACB, and so on and so forth. And then when we translate numbers back to the letters, only one of these combinations would have the numbers in ascending order. So therefore the answer must be 1 in 6. James, I did tell you it didn't need to be 1, 2, 3. I gave an example. So yeah, I'm not taking that as an excuse. They didn't need to be adjacent ascending numbers, let's say. So let's go on to the ants. We're in the corner of a cube of side length A. What's the distance it must travel? Shortest distance on the surface to reach the far corner of the cube. I had to change this because a couple of years ago, people thought the ant was just going to eat its way through the cube. No, it's got to be on the surface. So let's have a look at some answers. Oh, I saw a correct answer. Lots coming in here. So here there will be a square root involved. So let's see. We've got Adam ants. Ooh, close. Where's the A? Taylor correct. Yusuf is correct. If you've not got a square root in, and I'm just after one term, I don't want you to be adding 2 terms. So just one term that involves a square root and something else. Billy, close, but not quite there. Ben, yes. Albert, that's correct. Duneda is correct. So I'm just looking for the correct answers right now, because otherwise it's just carnage. So many people. I think this is the most people we've had since I've been helping out at these sessions, which is since it began. I need to get AI or something involved.
Absolutely not. What can I say, Justin? We're just good at getting the word out about the pet.
Now, Billy, correct. Fallet is correct. Nor's correct. Okay. We're getting quite a few correct answers, still lots of them with multiple terms. Okay. Top advice on 96 new messages. How can I read through all of these? Wow. Lots of correct answers coming in. So top advice is draw a diagram. So if you were to draw a diagram, let's move the chat over here so we can have a look. Where's my diagram gone? There it is. If we take a cube and we flatten it out and make it 2-dimensional, you might remember making these things in primary school. It's called a net. So you can fold it up. So if we wanted to go corner to corner, once it's folded, you're basically doing this journey. That's what the ant has to do, that journey. And then again, it's just Pythagoras. So that's root 5a. in there. So it's crazy when we look at this. So many wrong answers. Quite a lot of correct answers as well. But a question like this, we shouldn't be getting that many wrong answers. So were we drawing diagrams? And if you were, what diagram were you drawing? If you draw this diagram, it's very hard to get it wrong. So really good starting point. Translate the words into a picture, and then you'll have a much better success rate as we move on. Okay, we're going quite quick. This is one of my favorite problems. This one's going to take a while. So let's imagine this. Each summer, when the grass grows to a certain height, the groundsman, this is a cricket pitch, by the way, goes to the uniform cow shop. He was thinking about getting a lawnmower, but the price of diesel is just going way up, and he thought it's going to be a bad investment. But he had a friend in the field next door who was also strapped for cash because he's a farmer and we've lost all of the European Union incentives after Brexit. So he says, I'm going to diversify. What I'm going to do is I'm going to rent out my uniform cows. And what they will do is they will graze your field for you, so you don't need a lawnmower. So the groundsman says, great, brilliant idea. I'm going to go and get some of these cows, and they graze on the field. And after 4 days, the grass is down to an acceptable height. Perfect, job done. He was able to get 6 cows in that first year. Second year comes along, and the same problem. The field is overgrown. So he goes to his neighbouring farmer and says, let's have some more cows, please. He says, well, business has taken up. I can only give you 3 cows. He said, great, 3 cows will be fine. Turns out it takes 9 days for them to do the same job as the last year. In the following year, there's only 1 cow that's available. Ooh, danger. How long is this cow going to take to graze the field down to that level? So I've seen the correct answer come in from Matthew. Let me just scroll back up, see if there's any other correct answers that I can see. And I think we're back on to the previous question there. So far it's just Matthew, William, it's longer than that, Nishant, less than that. Imogen, correct. It is going to be an integer number of days. While I like tricky questions, I do like nice integer answers. Billy, that was correct. So we can work them out even without a calculator. Bit harder this one, but yeah, calculator's not quite necessary. So I'm seeing lots of people give answers that are too low. We've had one answer from Nishant that was too high. We had 3 correct answers so far. Ah, Johann's 4th correct answer. Everything else is too low. 3 days. 3 days. Just mad. Uh, Ryan, correct. Demir, correct. Robin, correct. Okay, what's that? 6 people so far out of like 166. Ooh, M, correct. Timothy's correct. Lucas is correct. When you get it correct, you shouldn't be putting a question mark. You'll know that you've got it correct if you've got the right method. Daniel's correct. We might be getting into double figures now. So why is it non-linear? If it was 8 days for 3 cows, the answer would be obvious. So figure out the reason for why it's not 8 days. Daniel's correct. Everyone else is still too low except for Sed. Sed is too high. Lots of people saying 27 days. It's more than 27 days. Dave is correct. Okay, Nada suggests it's non-linear because we don't know the specific heights and it might change every year. No, that's not the reason. It's the same starting conditions year on year. GKM, that is too high. Alistair, too high. But where are your units? Rodrigo, you've got it correct. Gabriel is too high. Okay, somebody who got the answer correct. Do you want to just tell me why it's non-linear? Can we answer what's going on for this first question? Trav is correct. The grass is growing. Yes, the grass is growing. So when we need to factor that in, think about units. A very useful unit
I
is,
think you've got more people who have realised that the grass grows than you usually do, Justin.
well, there are more people here than there normally are. So it's, I don't know, as a percentage, it's,
I don't know.
we'll have to do the stats.
Yeah.
Well, that's not good news for these guys because it means it's going to be harder for them to get into Oxford and pass the Pat if everybody's really smart. Hmm. So yes, correct answers from Tanishka, Maitrier, Lily, Gracie. I might have missed a couple. And then Maya, correct answer. So if we think about cow days, what does a cow day represent? Sounds like an interesting unit, but we use units like man hours, or if we want to be PC now, I suppose people hours. And a man hour or person hour represents an amount of work. So a cow day represents a volume of grass. That is how much grass one cow can eat in one day. Albert, that's correct now. So let's move through this. So the initial volume of grass is the same, but in the first year, the volume that is consumed is 24 cow days. 6 cows chewing for 4 days, consume 24 cow days. In year two, we consume 27 cow days worth. 3 cows chewing for 9 days. So how do we work out the growth rate? Well, in year two, it's an extra 5 days. So we've consumed an extra 3 days, 3 cow days worth of grass in 5 days. So the growth rate must be 3/5 of a cow day per day, which is not to be confused with a cow. So 3/5 of a cow day per day is the growth rate. So we've got an initial amount of grass, which is 24 cow days worth. It's growing at 3/5. The consumption of one cow, by definition, is 1 cow day's worth. So it's growing and being eaten at the same time. So the net progress that the cow is going to make is going to, ooh, somebody's at the door. Is going to chew 2/5 of a cow day per day. And then we just work backwards. I'm just going to answer the door very quickly and leave you with this question. One moment.
Don't worry, we've not all abandoned you. I'm right here. We've one or two of you who have said that the explanation is quite fast. Please do not worry too much. We've got a huge number of really exciting problems, so we are moving quickly today, but you're going to have a look at the recording and you're absolutely going to be able to watch this again as well and slow down. There are also some hints and tips for these questions in the link that I've shared. So you'll be able to take a look at some hints and tips as well. I just
I'm
used that
back.
time to reassure people who thought this was going very quickly that they can watch the recording and there are some hints
Yes.
and tips as well.
Okay. What's the question? Good point. Okay. So I don't know if you've watched The Terminator, but it's inspired by Terminator 2, actually. No, it's Terminator 1 because it's got Carl Reese in. So anyway, Kyle Reese and Sarah Connor, they're living off the grid. Because otherwise the Terminator will be able to track them down and terminate them, because that's what Terminators do. Of course, I'm a Terminator. So they're living off the grid, and Kyle's got a bit of a dodgy leg because there was an explosion. He blew up a Terminator and he got a bit of metal pipe through his leg, so he's kind of like crawling around and he can't really do a lot. So Sarah, what was it Sarah who did? Oh, it's been a while since I've watched the movie. Anyway, one of them can't really walk. So they're living separately, but they don't have running water because they're off the grid. So every day, what one of them has to do is go to the local river and get some fresh water. So they go down to the river with a bucket, fill it up with water, and then they take it to the other person's hideout. This is obviously, it's a long journey because Kyle lives 2 kilometers from the river, Sarah lives 3 kilometers from the river, and laterally they're 12 kilometers separated. So I don't want to walk any further than is absolutely necessary. So what's the minimum distance to go from Kyle's house to Sarah's house via the river? And you're not going to jump in the river and try and swim because there's piranhas in it. So lots of people tried that last time. So I had to get piranhas. Yeah. You're just walking on foot. And again, if you can do it without a calculator, that would be great. And if you can do it the clever way, that would also be great. The answer to the previous question was 54 days. If I skipped over that, it wasn't even somebody at the door for me. They were just ringing the doorbell for, I don't know, someone else. So lots of right answers here, actually. Matthew, Dinanda, Adam, show me you're working as well. Dinanda, thank you. Lily, Isaac, that's too far. My legs will fall off if I walk that far every day. Johan, correct. Billy, correct. It's going to be a nice answer, Joel. All of these are nice answers, except for question 9. Oh, the next question. Imogen, correct. Julian, without a calculator, please. Don't give me a calculation, give me an answer. Evie, correct. Rio, correct. Williams, correct. Demir's correct. Asal is correct. Wayne's correct. 14 meters? How are you doing that? 6 kilometers? How are you doing that? Gracie, units. 11 kilometers. We're more than 11. Just going direct is more than 11 kilometers. Okay, M, correct. Using vectors. Oh, that's all right. No, I can kind of see what you're doing there. Miles, if you used the appropriate units, you might be correct. Rakshan's correct. Angelina's correct. Lots of people saying square root of 145. I don't know what that is, but I know it's incorrect. Yes, Miles, you can move on to the next question. Archer's correct. James is correct. Katie's too high. Leo's too high. Isaac's correct. Elspeth is correct. Alistair's too high. I mean, the starting point is if I just walk straight down, 2 plus 12 plus 3, that would be 17. So anyone getting an answer more than 17, we've not understood the question. Yusuf's correct. Taylor's correct. Colton, Emily, Zamir, and Rodrigo, correct answers. So let's have a look and see what we're doing here. GKM, nice numbers. I'm giving you nice numbers, but how can it be less than the distance just walking direct from Kyle to Sarah's house? There's no wormholes involved. So what we might do if we were a mathematician, and I guess all physicists of, we're kind of mathematicians, but we try to be a little bit better than a normal mathematician, is you might pick a random point along here and say, I'm going to call this distance x, and then this distance along here would be 12 minus x, and then I could set up my total distance, which is going to be 9 plus 12 minus x squared plus square rooted plus x squared plus 4 square rooted, and then I could differentiate that with respect to x, and I could try to work out where that derivative was 0, and that could be my minimum. And that's an approach that some mathematicians would take because that's how you find a minimum. You set up an equation, you differentiate it, and that's what they've been told to do. However, let's be a little bit better than that. What we could do is we could look at these triangles here, and we could realize that the fastest way between 2 points is a straight line. Well, something that travels in a straight line, I'm going to ignore general relativity here, is a beam of light. So I can imagine that I'm shining a beam of light and this river is actually a mirror. And this would take the shortest possible path via the mirror. So I would know that these angles are the same. Yeah, angle of incidence, which is actually this angle if I'm drawing the normal in, is equal to the angle of reflection. So these angles must be the same. So I've got two similar triangles, right angle triangles. This is length 2, this is length 3. So that's quite useful. So I can split up this 12 into 5, and this will be 2/5 of 12, and this will be 3/5 of 12. So I don't need to do any calculus at all, and I can do it that way. So that's fine. That will get you there, but you're probably going to need a calculator if you're going to do that. Who was smart? Who did it the smarter way? Okay, Mahika says she did. Mahika, can you explain to me what you did to convince me, to make me believe you? Yeah. Okay, Ryan's given me a keyword. That makes me think I know what's going on there. Hassal as well. Thank you. Okay, so the key thing here is we can reflect it. So we can actually make this a straight line, and we can imagine that we're going to the image of Kyle's house over here. So we just travel in a straight line. So we just have one triangle. So the length of this triangle is now going to be 3 plus 2 along here. So it's going to be 5 down and 12 across. And then hopefully you recognize that 5, 12, 13 is another Pythagorean triple. And we can go from there. So using this kind of reflection idea can be very useful. An
We've had
example.
someone, Justin, ask you just to explain again why those angles are the same. I think they missed your analogy.
Okay, so the analogy is that light travels the shortest path, which is in a straight line. So if we imagine that we replace the river with a mirror and we wanted to shine a light from Sarah's house to Kyle's via the mirror, then it would have to follow this path. And this would be the shortest path. So we know from the law of reflection that these angles needed to be the same in there. Speaking of light, if you imagine that you're looking at a fiber optic cable and you've got the beam of light that travels essentially straight through, if it's a nice straight cable, and you're looking at optical dispersion because you might have a ray that is reflecting up and down, back and forth as it goes, and you want to work out how the distance that has traveled, you could essentially think about it as reflecting rather, so doing the image and drawing a straight line rather than counting the reflections. So that might be another example where you try to do this. Another time where you might come up with an image would be if I'm looking at electric fields and I've got two charged objects and I want to know how they interact. Well, instead of having it something positive, I could turn it into negative, but I could reflect it onto the other side in a sense. You kind of like need to see the examples before you apply that technique. Um, but it does come up quite often, things like that. Okay, not a nice number for the next question. Let's go and have a look at some little diagrams there, just showing how to do that. A journey. We're going to go from Newcastle to Oxford on a coach or maybe a Flixbus. There's lots of Flixbuses going around now. They're quite affordable, certainly compared to trains. And it's good. It's a good day. Traffic is free flowing. So the thing that determines the coach's speed is whether it's going uphill, downhill, or traveling on the flat road. So we've got these three scenarios. So it travels at 63 miles per hour regularly if it's on the flat road. If it's going uphill, then it's 56 miles per hour, or downhill, naughty, naughty, 72 miles per hour. So when we go from Newcastle to Oxford, it takes 4 hours. But when we go back from Oxford to Newcastle, it's an hour longer and it's the same route. So how many miles is it on the coach between Newcastle and Oxford? Now, I love this question because it seems like we don't have enough information to answer it. But of course we do. Okay, so let's have a look at some answers. Ryan, you have the correct answer. Gracie, units, please. Evie, too few. Jasmine, too many or too high. Demir, correct. Okay, if you popped in an answer while I was still talking, I've missed it, so feel free to pop it back in. Denardia's correct. Kelvin's correct. Daniel's correct. Rakshan, too few. Billy's correct. Emily, there's no units, but if we do a reality check, does that make sense? Ria, your answer to 4 sig figs is correct. Is it correct to 5 sig figs? I don't know. I've not noted it down to 5 sig figs. I'm tempted to say you must be correct. But I have a 4 sig fig answer. I don't know what the 5th sig fig is until I calculate it again. Johan's correct. Izzy's correct. I thought it was an exact answer to 4 sig figs. So really, you've confused me. Afifa, you're doing question 9? That answer can't possibly make sense. Samuel was correct. Okay. Rio, I know the answer to 4 sig figs is that. I'm just wondering whether your answer was exactly that or the answer that you actually put in. Jasmine's too low. M is correct. Leo is correct. Okay, M, thank you for showing me your method. Is that the best way of doing it? I don't have any 252s in my methods. Did I? Maybe I did. Maybe I just didn't write it out. No, I had double that, but that's fine. Uh, so Denario, question 10. Perfect. Nada, too few. Owain, too many. Let's start dropping some hints. So let's label these distances for downhill, flat and uphill. If we call them X, Y, and Z, that's not much of a hint. Let's have a look at the next one. So when we reverse the journey, X becomes Z. Oh, sorry. Y and Z switch, but the X, know what I'm doing. Y, the flat bit, stays the same, but X becomes Z and Z becomes X. So let's apply some physics to that. Yusuf, it's not an integer, but it's as close to being an integer as it would be if it wasn't an integer, if that makes sense. When you get the answer, hopefully it will. A, too few. Afifa, too high. Yusuf, units. Units, Falet. Ah, there we go, Yusuf. Correct. B, what? No. What? EV, too few. Timothy, correct. Rodrigo is too high. M, you've got number 10 correct. Alison, you're too high. Amino, I don't know what you're telling me. Ryan, question 10 is correct. Demir, question 10 is correct. Mark Shan has got this one correct. Said is too few. Okay, let's have a look at the physics. Let's set up two simultaneous equations. The only physics we really need here is speed, distance, and time. So these are your two equations. Now it's just math. But two equations, three unknowns. This is the problem. How do we solve that? Said you are too few. EVs too many. Manahill too few. And if you let's do a common sense check. If it was all uphill and I'm traveling at 56 miles per hour for 4 hours, how far have I traveled? It's got to be more than that. So that's a lower limit. What if it was all downhill? 4 hours at 72 miles per hour, that's your upper limit. So if you've got answers that lie outside those ranges, then it's got to be wrong. Okay, where are we? Evie, we've said was too high. Gracie for question 10, that's correct. Leo, that's outside the range that I've just talked about. That's too low. Evie, too low. A, too high. Okay, we're slowing down now. But the next question's quite quick. So I'm going to give this one a little bit more time. And I might throw some bonus questions at you, actually, that aren't on the sheet. I've never done that before. Ooh. So what is it that I actually care about? I don't care what X, Y, and Z are. I'm not trying to find X, Y, and Z. What am I trying to find? No, I don't care what Y is. I don't care what X is. I don't care what Z is. What is the question asking us to find? I do care what X plus Y plus Z is. So that is the thing that I care about. And the only reason that this is solvable is because I've given you particularly nice numbers. What's so nice about these numbers, 63, 56, 72? If this was 55, you couldn't solve it. Factors. They're not all multiples of 7, are they? 7 times table, 72. Are they all multiples of 9? 56, is that a multiple of 9? Multiples of 8? No. You're there, but you're not there. Oliver, you are there. Multiples of 3. 56? Don't think so. Ah, so we're spotting something. So what we need to do is multiply everything by 504. Why 504? Lowest common multiple. 7 times 8 times 9. So what happens when you multiply everything by 504? Let's give this a couple of minutes, a whole bunch of cancelling. Everything becomes an integer. We get rid of these annoying fractions, basically. So let's do it. If you've not done it yet, let's do it. While you're doing that, I'm going to give a question for the people who've moved on and got question 10 correct. Listen very carefully. I have two fair coins, head, tail, normal coins. You're familiar with what coins are. I toss them both simultaneously. They go up in the air and they land, and I observe the result. Having done that, I then point to one of these coins and I tell you honestly that this coin that I'm pointing to is a head. What is the probability that the other coin is also a head? And my silence will remain until somebody gets the right answer. Oh, Tanishka, I thought I was going to have a rest, and Leo. Well done. Taylor, well done. Ryan, Ihan, and Kelvin, and Ben. Okay. Some good answers there. Getting the usual incorrect answers. Chinmay, where are your units? Probably more incorrect answers than correct answers for, thank you, Chinmay, for that bonus question. So when we multiply by 504, we get 9x plus 8y plus 7z is 504 times 4. And Demir correct and Am correct for the bonus. And the other side becomes this. Now, if I add these two equations together, I get 16 lots of x plus y plus z. 16 lots of what it is that I'm interested in is equal to 9 lots of 7 times 8 times 9. So that's just math at this point. So 283.5 miles. Lovely. Gracie, yes on the bonus question as well. So let's have a look at the normal question for the rest of us. And I'll give you another bonus question that's similar to that one. Um, yes, your answer is correct. So, time to find out, the age-old question, who would win in a fight between a ninja and a pirate? So they're going to have a battle to the death. They start off 90 meters apart, and the pirate essentially hobbles along towards the ninja. He's got a peg leg, so he's hobbling along at an average speed of 2 meters per second. Let's assume it's constant. Let's do that. The ninja, he's a little bit stealthy. He's like, I'm coming forward, I'm going backwards, you can't see me. But on average, his drift velocity, let's call it, is 4 meters per second. But the pirate has his animal companion, the parrot, who is very well trained. They've got a very good relationship. So the parrot has been trained to go flying at a constant 8 meters per second to the ninja, looking him in his eyes, seeing if there's any chink in the ninja's armory that he can see. And then he's going to bounce back elastically to the pirate. And when he gets to the pirate, he's just going to squawk his intel, and then he's going to bounce back elastically off the pirate and go back in for more intel. And he's going to do this going backwards and forwards until eventually he's crushed between these two unstoppable forces. What's the total distance that the parrot travels? Lots of correct answers coming in here. Let me see if I can highlight some incorrect answers. Hassal, too low. And A, too low. Strange. Same incorrect answer. Ben, too low. Yeah, surely these low answers we can apply some kind of like reasoning to realize that it's got to be more than that. Miles, that's a decent answer, but it's still too low. So for the sake of the bonus question, most people will tell me it's a half. It is not a half. Then they might say it's a quarter. It is not a quarter. Then third time lucky, they get the right answer. Okay, Afifa, you're the third person who said 15 meters. I can't fathom where that comes from. Uh, Maya, that is too high. Ileana is too high. Yusuf, show me some working a little bit. Thank you. Maybe that's where the 15 comes from. The 15 is time, 15 seconds perhaps. Jasmine's too low. Lucas is too low. Daniel's too low. Nishant, I don't know what you're telling me here. If I'm not telling you you're incorrect, assume you are correct. The FIFA too low still. So the key thing to solving this problem is time. And I've given you enough time for this. Let's maybe give you some bonus problems or maybe move into, yeah, I can go into the next session. There's a particular problem there that if I get it out of the way, you might like me in the final session because that's the question that makes people not like me. So I think I'll show you that one. So if we were doing this mathematically, our friend, the mathematician again, could come up with an infinite sum. They could work out at what points along here, this 90-meter path, there is the first collision, and then work out the distance that the parrot has traveled. And then at this time, see where the pirate is along here, and then do the same iterative process to work out where this next collision is, and backwards and forwards and form an infinite sum. Yeah, that's one way of doing it. And it's good to be able to do things like that. Infinite sums, they're quite important. We use them a lot in physics, but we don't need to do it that way. There's a much simpler method, which I imagine most of you got as we got it quite quickly. Mal is too low. Ava's too low. Rayhan is too high. Isaac's too high in there. So somebody said 4 trips. There's going to be an infinite number of trips, but we are going to converge to a sum. So what we want to do is look at the ratio of speeds here. So let's ignore the parrot for the moment and look at the ninjas traveling at 4 meters per second. The pirate is traveling at 2 meters per second. So overall, their relative speed is 6 meters per second. That's how, the distance that they are closing on each other every second is 6 meters. It's 90 meters before they collide. If we're closing in at 6 meters per second, we can work out that that's going to be 15 seconds until they collide. So if we know the time that the parrot is flying for, and because he's colliding elastically, he's traveling at a constant speed of 8 meters per second, we can therefore work out the total distance, which is just going to be 120 meters. So that is a very quick method. So the bonus question, the answer was a third. Let's think about this very carefully. So I tossed 2 coins and they landed. I have then observed them. And having observed them, I make a selection. They are no longer independent events. I don't observe coin 1 and then ask you about coin 2. I'm not labeling them. I am selecting which of these coins I am telling you is ahead. And the only way that I can do that is if they've not both landed tails. So when it's an independent event, there are 4 possibilities. Heads, 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 tails, tails, heads, tails, tails. Me then telling you that one of them is ahead and a specific one is ahead tells you that it can't be tails, tails. I've not told you which one of them is the head, whether it's coin 1 or coin 2, if you want to label them. So you still have 3 possibilities that are all equally likely. So the chance that the other one is ahead is if it was head-head that it had happened. Let's see if we understand that and practice another question. I have 3 children. I don't. I only have 2, but for the sake of this question, I have 3 children. I pull out a photo of a beautiful baby girl from my wallet and say, this is one of my children. And people go, oh, that's nice. I then ask you, what's the probability that I have 3 daughters? Did we follow that bonus question? Can we answer the bonus question? Iris, no. Dan, no. Alistair, no. Sophia, no. A, no. Ava, no. Tiffany, yes. Katie, no. Evie, no. Leo, no. Izzy, no. Miles, no. Rakshan, no. Ellen, yes. Victoria, no. Brian, no. Iris, no. Rao, no. Just no, 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 no's. What's that? 2 people have got it so far. So Owain has got it. Eric has got it. So I have 3 children. Just repeating the question. I pull out a picture of a beautiful baby girl from my wallet and show it to you. This is one of my children, I tell you. I then ask you, what's the probability that I have 3 girls? Gracie, yes. Lily, yes. Lots of yeses coming in now. Kelvin, Ryan, Angela was. It's moving too fast. But yes, the answer is 1 in 7 for the same logic that we had before. So with 3 children, there are 8 possibilities. But by showing you a girl, I've not told you whether it's my first, second, or third born. All I have done is eliminated boy, boy, boy. So there's still 7 possibilities that are equally likely. And only one of those 7 is girl, girl, girl. Classic Monty Hall problem. I think lots of people are familiar with Monty Hall. Let me just.
I've just shared a link to the Wikipedia page
Yes.
on Monty Hall in the chat.
5 minutes of torture to go. Let me.
Oh, I think people are having fun. You can
I'm
use the
having fun.
reactions and let us know if you're enjoying it.
This is one of my favorite problems. Here's a triangle. Oh, filling me with warmth.
There you
What?
are.
I don't know what
Look how
emojis.
happy
Are there
they are.
negative emojis available? Or do
Not
they
on our
just have
platform.
options of shock? So we have a triangle represented here with side lengths A, B, and C. A is 9 centimeters, B is 16, and C is 25. I would like to know what the height is, or the mathematicians would call it the altitude of the triangle. Where's my chat gone? Let's get this back up. Demir and Victoria questioning reality. A, correct. Even without the units, I suppose. Oh, is that too much of a clue? Yes, Victoria. Ruben, if you want to try doing that, you can. Um, but none of these questions I've needed a calculator for so far. Am I going to change the habit of a lifetime? A few years ago, there were no calculators allowed in the PAT. Hmm. Kind of limited the questions that could be asked a little bit. Okay, Tiffany is correct. Owain is not. Zarin is not. Colton is. Uh, Kelvin, it's not impossible, is it? But it is the correct answer. Oh, Colton thinks it's evil. I know, but I like it because it's teaching an important teaching point. Billy, no. Denadia, yes, but you're questioning. You've been so confident up until now. Evie, no. Fabian, no. Hugo, yes. Yes. William, yes. I can draw a diagram how I want, just maybe not to scale. Uh, Iris and Archer, Ben, yes. Alistair, no. Timothy, no. M crying emojis. That's just the reaction I'm after. Johan, no. Yeses for Rosa, Emma, and Taylor. No for Billy and Jasmine and Jedediah? Jedediah. GKM, no. It's getting late. Zarin, yes. No, Emily. I mean, people are forgetting units now. So, Robin, what is the answer then? Yes to Imogen and Thomas. Thank you for correcting yourself with units. Adam, no. Where do I find these evil questions? Hmm, I forget where I got this one from. But the nice thing about this is, again, a primary school student could answer it, which is what I like. The problem is you might know too much if you're thinking about trying to use the cosine rule and all sorts of other things and Pythagoras. You don't even need Pythagoras for this. All you need is a ruler, square root of 337 units. Surely you mean centimeters, but no. Jasmine too high, Izzy's too high. Rayanne, yes. Jasmine, well done. You took the primary school approach, and then hopefully you realized. The rest of you, you are going to kick yourselves rotten. Maybe draw a scale diagram. Mahika, no. Isabel, no. Ruben, no. Mahika's drawn a scale diagram and still not got it. What ruler are you using? Ruben and Evie, no. Harry, no. Yes, Robin. So what is the answer to my question? After a numerical answer. Leo, too high. You don't need a ruler. You can maybe do it in your head. Yeah, draw a scale diagram in your head if you can. Um, Lots of answers that are too high. Strange that we've not had any answers that are too low. Maybe that's a clue. It requires a compass. Okay, yeah. This one doesn't require a compass. -10, Robin. Well done. Too low. Still getting wrong answers in. What is 9 plus 16?
I'm going to turn the chat on and wait for the comments to come through.
Okay. Oh my days. There we go.
There we are. That's the reaction you were hoping for.
Am I the guy, Robin, or is that a trick? Yeah, I mean, there were supposed to be tricky questions. This one is the one that I would probably class as a trick question. But the point that I'm trying to make is valid, I think. Lots of
Absolutely.
people would look at this diagram and assume there's a right angle because of the way that it's drawn. Or you might see the 9, 16, 25 and go, ah, Pythagoras. Yeah, there's a no, 3, 4, 5 is Pythagoras. So you may be making assumptions here. Don't make those assumptions.
And the person who said if this was in the pat, it would waste so much time. We probably wouldn't put this in the pat.
No, it'll be like 169, 25, 144 triangle.
Yeah.
Yeah, have some of that. So back to basics. Step away. Is there another approach? Don't be a mathematician and think just because I know Pythagoras and the cosine rule, I'm going to dive in and solve it. Yeah. That's been the message over these 12, 13 questions that I've given you. Yeah, try to have some out of the box thinking. That's what makes a really good problem solver, and that's what physicists should try to be. I've got a couple more of these questions that we're going to do in the next session in 2 weeks with me, and then we're going to get into like proper physics questions, looking at circular motion and things like that. Have a bit of a focus.
Lovely, thank you. So on that note, because we always get loads of questions, we've got about 30 seconds before we're officially running late. Lots of you will have noticed that in the PAT syllabus, simple harmonic motion isn't specifically there. The reason we talk about this and we do a bit of extra on circular motion is because it is excellent problem solving. Absolutely excellent problem solving. And even before I got that sentence out, someone had put it in the chat. Justin, wait, we need to know simple harmonic motion? Not strictly, but actually simple harmonic motion can come up in a problem solving context really easily without asking you it in that form. And it is just really, really good problem solving practice. So everyone, thank you so much for coming today. It looks like loads of you had great fun. It was lovely seeing so many answers coming through. Tomorrow morning, I'll share the recording so that you can have another go through this. We know we do move very quickly in this particular session. So tomorrow we'll share the recording. I will also share the problems to be solved in advance of next lesson so that you can get stuck into those. And we'll be joined by three of our lovely undergraduates who will take you through their solutions to the problems. Justin will then be back in 2 weeks' time to take you through our final study focus session, as he just said, with lots of circular motion and things involved. So thank you very much, everyone. We'll see you next week, and Justin will be back in 2 weeks. Bye, everyone.